Okay, let's go ahead and talk about some applications of sine and cosine waves, because it's one thing to just graph it, be able to throw it into a calculator, but most of the time what you're going to have is you're going to have data that you're going to have to turn into some sort of application. And so in this case we have just a very basic example. If the temperature is sinusoidal with the coldest day of the year on January 31st at 1 degree Fahrenheit and the warmest day of the year is 102 degrees Fahrenheit, find the amplitude, period, frequency, vertical shift, horizontal shift, and equation, then graph. So from this point, let's see what we can do to try to make an equation out of all of this information. First things first is you have to figure out where to start. Well, seemingly enough, it would be January 1 as day 1. And you have a total of 365 days. So your period is going to equal 365 days. So with a period of 365 days, that gives us something to start with, because now frequency is going to be 2 pi over period. So that's going to be 2 pi over 365. Now, with that, we start plugging in a couple other pieces of information. If my max day is at 102 degrees Fahrenheit and my min day is equal to 1 degree Fahrenheit, that gives me a couple pieces of information. Number one, it means that I have a total height here of 101 degrees Fahrenheit. Now, 101 degrees Fahrenheit doesn't really help me a ton, because from any sine or cosine wave, the total top to total bottom is not what I'm looking for. I'm only looking for the distance from the middle to the top or the middle to the bottom. So in this case, we would say the amplitude is going to be 50.5 degrees. 50.5 degrees. So now if you have those pieces of information, you can also now find the vertical shift. Because in our case, it doesn't look like this. It's actually going to hit bottom at 1, and it's going to hit top at 365. So the middle is actually going to be 1 plus 50.5, or 51.5. So your vertical shift is 51.5. At that point, we now have a top, a bottom, and a middle, and we're almost home. Now, it says it's sinusoidal. Well, sinusoidal just means it's shaped like a sine or cosine wave. Now, by the way, it's shaped like a sine or a cosine wave, because if I graph sine x, that looks like this, with this being pi over 2, this being pi, this being 3 pi over 2, and this being 2 pi. However, if I were to graph cosine x, and I would say cosine x minus pi over 2, that means I would start not here and make it like this. I would actually start at pi over 2, then go down to the middle, down to the bottom, up to the middle, back to the top. So by taking cosine and shifting it by pi over 2, my cosine and my sine, instead of overlapping like this, they come into alignment and become the same graph. So whether you use sine or cosine for our application doesn't make any difference. It all is a matter of where you start. Now, our minimum happens on January 31st. Yes, January 31st. So if I were to break this graph up into January, February, March, April, May, June, July, August, September, October, November, and so on. January 31st is going to be right in here, almost at February. Okay? And it's going to hit top somewhere later. Well, there are 12 months in a year. It's going to hit top 12 months from here. So I go 1, 2, 3, 4, 5, 6. Oh, sorry, it'll hit top 6 months from here because it's half the distance. So 12 months total, half the distance. So 1, 2, 3, 4, 5, 6. And it's going to hit top at July 31st. That's one thing about sine and cosine is they are symmetric on either side. So if I have this, I have this curve right here. It is a curve. Remember, just like in February, it does begin to warm up, but not terribly fast. But then we get a good warm up before we get into the hot. But then the hot doesn't get too much higher. Then it begins going down again. So if we have this, well, the problem is this graph here doesn't look like sine or cosine. But since it starts at the extreme bottom instead of the extreme top, what I could do is I could use negative and cosine. Negative and cosine. Because it's like a cosine wave, but it starts at the bottom. So in this case, we already know what our vertical shift is, 51.5. We already know the amplitude. The amplitude is 50.5, and now that it's negative, it's flipped over. Frequency, we have 2 pi over 365. And the reason we're using 365 rather than 1 for 1 year is because when we come to horizontal shift, we need to be able to shift it an exact number of times. If we used years, what would from January 1 to January 31st be as a fraction? Well, since the months aren't even, we need things that are evenly spaced, so we're going to use days. So we're going to shift it from 1 to 31, which is a 30-day shift. Now let's double check that. So we're already at 1, so we go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Yeah, we should have 30 in toto. So, just double checking, we should have all those. So, if I'm not mistaken, this is going to be the equation we could use. Now, if you wanted to make it a sine, not a negative cosine wave, you would need to start it in the middle. Well, the middle happens 1/2 of the way between the two pieces. So if this is January 31st, and that's July 31st, I could go 1, 2, 3 units over and have it at April 31st. So if I have April 31st, that would mean I'm starting well further over here. It's going to go up, down, back up, starting at April 31st. But now I could use sine. My vertical shift doesn't change. It is plus now because we're starting in the middle going up. The amplitude doesn't change. The period doesn't change. And neither does the frequency. What changes is the horizontal shift. So I need to shift it over to April 31st. Does that even make sense? No, it'd be April 30th, so it'd be May 1st. The idea here is what you would need to do is you would need to shift it 1/4 of 365. 1/4 of 365 because the difference between cosine and sine, the difference between cosine and sine is 1/4 of its period. So 1/4 of the period, so if I take 365 divided by 4, and so you're going to come up with 91 1/4. So 91 1/4 added on to the 30 we've already moved. So we come up with 121.25. Now, obviously, if we're dealing with days as our minimal unit, the 0.25 we can eliminate. So, again, there's a couple different things. We're going from a real-life situation, sort of, to a pretty and contained equation, or two in this case, based on the graph. The ideas are all the same. We can squabble over how do you count this day, what day do you start with, do you count on this, but the idea here is can you find from min and max and amplitude? Can you find where you're going to shift the middle to? And can you determine from a period, and from a period determine a frequency, and from there can you move it left or right to make it appropriate? By the way, there are way more equations than this that you could do. Using this type of information, we will be doing some more applications in class. So, there you are. Here you go, ladies and gentlemen. Here is an application problem from real life. And for all you Aikmans out there, we have a little surprise for you. This is the information right off the company website for the number 16 Big Eli wheel. And so you need to make sure that you copy this problem down and do your very best to come up with all of the information as in the previous problem. Amplitude, phase shift, horizontal shift, whole 9 yards with a graph for the whole thing right there. So take a look at the problem, do your very best, give me all the information for tomorrow.